Hi, my name is Jacob Windel, one of the co-authors of the Mind Action Series textbook range. In this video, I would like to discuss with you our approach to the general solution of a tan equation. You might have noticed in our grade 11 and 12 textbooks, we have used a somewhat different approach to the usual. So as an example, let's use the equation tan theta equal to 1. As with any trigonometric equation, we always start by finding the reference angle on our calculator. So we say inverse tan of 1, and that gives us our reference angle of 45 degrees. Next, we determine in which quadrants tan is positive in this case, because in this equation tan theta is positive 1. So that is, of course, quadrants 1 and 3. For quadrant 1, we use the reference angle as it is. So that's theta equals 45. For quadrant 3, we use 180 degrees plus the reference angle. That is 180 degrees plus 45 degrees, which gives us 225 degrees. Now, we add to each of these basic solutions k times 360. Now, some have said, hang on, this is wrong. This should have been 180 degrees. No, it's not wrong. We have used a different approach. We have added full revolutions to the basic angles instead of using the period of the tan graph, which is 180 degrees. Of course, the conventional method of using the period of the tan graph is completely valid, and in that case, you only need to use one of the two angles. You don't need to use both of them. You could simply say 45 degrees plus k times 180, and that single solution will give exactly the same answers as the two solutions that we've given with the K360. The reason we have opted to use K360 in our textbook is because this is consistent with the approach we use for sine and cos. So then we have only one method for sine, cos, and tan. And that method is based on finding the correct quadrants and then adding any number of revolutions represented by the K360. In this video, I will explain to you why these two methods are exactly equivalent. Let's get on to it. So I want to show you that the solution 45 plus K180 gives exactly the same final angles as 45 plus K360 or 225 plus K360. Let's start with 45 plus K180 and see what angles we get from that. The first angle is the 45 degrees itself, and that is, of course, in the first quadrant. Now we are going to add multiples of 180 to that. So let's start by adding a single 180 to 45 degrees. Remember, when we add, we go anti-clockwise. So adding 180 to 45 will take us into the third quadrant, and that will give us the angle 225. We add a further 180 to this, and that takes us back into the first quadrant and gives us the angle 405 degrees. Now we're just going to carry on with this. So we're going to add another 180 to 405, and that gives us 585. And if we add another 180 to that, that takes us back into the first quadrant and gives us 765. And a final 180 that we're going to add to the 765 brings us to 945 again in the third quadrant. I'm not going to add any more angles. I think this will be enough. Just for fun, remember that we can also replace the k here with a negative number because k is an integer. So we can also subtract multiples of 180. So let's subtract one or two multiples of 180. Now, of course, when we do that, we are moving in the clockwise direction. So let's start with 45 and subtract 180 degrees. That takes us into the third quadrant, and 45 minus 180 gives us negative 135. And then if we subtract a further 180 from that, that gives us negative 315 degrees, and that is again in the first quadrant. So now we've got 4 angles in the first quadrant and 4 angles in the third quadrant, all from the solution 45 plus K180. Now let's see what happens when we use 45 plus K360 or 225 plus K360. Now, when doing 45 plus K360, I am going to mark those angles in red so that you can see that all those angles come from 45 plus K360. So the first angle we get is, of course, the 45 itself. I'm going to circle that in red there. We already have that angle from the previous approach. So I'm just going to circle it in red there to show that it comes from the 45 plus K360. Now, if we add 360 to that, we are going, remember when we add, we go in the anti-clockwise direction. So add 360 to 45, and that takes us all the way back into the first quadrant, and that brings us to 405 degrees. And if we add a further 360 degrees to 405, that takes us back into the first quadrant again to 765 degrees. And then again, as we did with the 45 plus K180, I'm going to also subtract a 360. So that is when we replace K with -1. So if we subtract 360, that means we are going clockwise. So let's go clockwise from 45. And that takes us to -315 degrees. So you can see that the 45 plus K360 here gives us exactly the same solutions in the first quadrant than the ones we got from 45 plus K180, but it doesn't give us any of the solutions in the third quadrant. Now let's look at the other one, the 225 plus K360. The first solution we get from that is the 225. I'm going to mark that in blue here. So that's the 225. And then we're going to add 360 to that. Remember, that means we go anti-clockwise, 360 degrees, full revolution, anti-clockwise. And that takes us to 585. Add another 360 to that. Back into the third quadrant, gives us 945. And then if we subtract 360 degrees from 225, so from 225 we go clockwise 360 degrees, that gives us -135, also in the third quadrant. So as you can see, this part of the solution gives me the exact same 4 angles in the third quadrant than the 4 I got from 45 plus K180. So clearly, we get exactly the same angles from the approach of using the 2 different quadrants with the K360 as what we get when we use only 45 plus K180, which shows that the 2 methods are actually completely equivalent. Now, some people even use both the quadrants, 45 for the first quadrant and 225 for the third quadrant, and then still add 180. Now, if you do that, it's not incorrect, but it actually duplicates solutions, because from the 45 plus K180, we're actually going to get all 8 these solutions. And then if we use 225 plus K180, we're going to get all these same solutions again. So that's actually completely unnecessary. If you use K180 instead of K360, you only have to use one of the 2, and we'll normally just use the 45 because it's simpler. So I hope that clearly demonstrates that these 2 methods, using one quadrant with K180 or using the 2 different quadrants with K360, actually produce exactly the same answers, and therefore both are completely correct. So, since both these approaches give exactly the same angles, which ones should we use? That is entirely up to you. We have opted for the first one, using the 2 quadrants where tan is positive and adding K360, because it is consistent with the approach that we have used for sine and cos. And so we have only one method in solving trig equations. Thank you for watching our video. Goodbye.